Let me talk a little bit about angles and degrees and radians. Uh, Let me point out to you that I think you're pretty familiar with the concept of a circumference of a circle. The circumference of a circle equaling pi times the diameter of the circle. Um, the, that's uh, that's where the number pi comes from, is that connection between circumference and diameter. We can also rewrite that in terms of radius by saying that 2 pi times the radius would give you the circumference of the circle. What we're going to work with is the fact that if you consider that a circle is formed by sweeping around 360 degrees, and this 2 pi, we're going to connect degrees and radians by saying that 360 degrees is equivalent to 2 pi radians, or one complete revolution is the same as 2 pi, which means that if we rotate or go 180 degrees, we could simplify it and say that pi radians is the same as 180 degrees. And you'll notice in these conversion factors or these statements that there's no units written for radian. Sometimes people will put rad for radian, but you don't really need to write a unit for radians. It's just 2 pi, pi. You can even have 1 radian or 2 radians, but you don't necessarily have to write a unit for it. But degrees, we want to put the degree symbol so we're clear on what a degree is. If we continue along with the same concept, if the full 360 degrees is 2 pi and 180 degrees is pi radians, then we could say an angle of 90 degrees is the same as pi over 2 radians. Then we introduce this new concept of an arc length. So if I sweep out an angle of 90 degrees, then on the outer part of my circle here, I have an arc length that's formed, and that arc length, when we go to figure out what its length would be, we could say that it's going to be 1/4 of my full circumference. So it's going to be 1/4 times by 2 pi times by r. And that gives you a formula for the arc length for this particular arc length. And if we simplify that a bit, we could recognize that if we figure out the arc length, it would equal 1/4 times 2 ends up being pi over 2 times the radius. And if you take a look at the two formulas, the circumference formula is 2 pi times r, and the arc length here is pi over 2 times r, and that works. This particular arc length works when we have an angle of 90, and you'll notice what happens here. When we look at the full circumference, we say that because the angle is 2 pi, it's 2 pi times the radius, and 2 pi comes from the fact that it's the same as 360 degrees, whereas when we look at an angle of 90 degrees, we could say that's the same as pi over 2 for an angle. Well, the arc length there then becomes pi over 2, which is the angle times the radius. So in general, we form an equation for the arc length, and we say that the arc length is just going to equal the angle in radians times the radius. And so this formula is a new formula that you need to get familiar with. It has to do with the arc length of any circle, and it doesn't have to be an exactly 90-degree angle or a 360 or 2 pi degree angle. It can be any angle you want, but if we want to find the arc length, we have to take the angle in radians times the radius. And what you'll notice is it kind of makes sense that this formula works for radians, because if we were to keep it in degrees, we'd be saying, let's say this radius here is 2. If we use 90 degrees, we'd go 90 degrees times 2. We'd be saying that's 180. There's no way if this length is 2 that that's 180. However, when you figure out what pi divided by 2 is on your calculator, you'll get approximately 1.57. Well, if you take and say this length is 2, and you times it by 1.57, yeah, that seems like a much more reasonable length. And that's why this formula here only works for finding the arc length if your angle is in radians. So that's a little bit about um, radians and arc lengths and the connection that they have with degrees. I'm going to show you a few more examples, but I thought I'd introduce that to you.
Okay, let me go through a couple more examples. One making use of the arc length formula, another one just changing from degrees to radians. So hopefully we are okay with the idea that if we want to find the arc length of a circle, we just have to find the angle in radians and multiply it to the radius. And that's called the arc length formula. So here's an example. We have an arc length of 6 centimeters and a radius of 3, and we're asking for the angle that's subtended or opens to this arc. And if we take a look, the radius is 3, the arc length is 6. So in our formula, we could just say the arc length is 6, the radius is 3, and that's a fairly easy formula to solve, and you get 2. Well, what is 2? Well, 2 is the radian measure of that angle. And so what degree is that in? Because 2 radians doesn't mean a lot to us. But if we take 2 radians and we want to change it to degrees, we make use of the conversion factor that 180 degrees and pi radians are equal to each other. So what we do is kind of like a chemistry concept or a science concept where if we're working with a unit and want to change that to another unit, we're going to cancel that unit out by dividing similar units. So we have radians here and pi is radians. So we end up, by dividing those, we end up canceling out our radian unit, and timesing by the degrees would give us an answer here that's in degrees. So if I correctly put the symbol there, we would find out that if we took 2 times 180 and divided by pi, we would get 115, and the units would be in degrees. We can also change degrees to radians. So if we have 75 degrees and we have to change it to radians, in that case, we would start with the 75 degrees. We would divide by the 180 degrees. That would cancel our degree units. And then when we times by pi, we'll get our radian unit. So in this case, take 75 times by pi, divide by 180, and you'll get 1.3 radians. This always confuses people, this pi over 180 thing. It's strange, but up here, we say that pi and 180 are the same value. So really what we're doing here is we're timesing by 1. Even though numerically it doesn't equal 1, 180 degrees and pi are the same value in terms of different units. Similar to me saying that 80 kilometers per hour and 50 miles per hour are the same. Those numbers aren't the same, but the rates are going to be the same. Because we're talking about 2 different units. So here we're really multiplying by 1, even though the numerical value of it isn't 1. Try not to lose too much sleep about it. We want to cancel radians, you divide by pi. If you want to cancel degrees, you divide by 180. Whatever you divide by, you times by the opposite. So if you divide by pi, times by 180. If you divide by 180, you times by pi. And that's how we're going to go back and forth between degrees to radians, between degrees and radians.